Good morning. Today we continue in thermodynamic chapters. In that, yesterday we completed enthalpy of chemical reactions, and today we are going to discuss the thermochemistry. Thermo means heat, and chemist means different reactions that takes place in the chemistry. Thermo means heat, means heat change in chemical reaction is called as thermochemistry. Another way thermochemistry is defined as the thermochemistry is a deals the change in enthalpy. Change in enthalpy. Enthalpy means heat. Heat change in chemical reaction that is called as thermochemistry. In that, first point we see enthalpy of a chemical reaction. First, enthalpy of chemical reaction. Denoted by letter delta RH. The enthalpy of chemical reaction is denoted by symbol delta RH. Here consider the agent of reaction. This reaction is A into A plus B into B gives out C into C plus D into D. This is the general chemical reaction. In this reaction, A and B are reactant and C and D are product. Here small a, small b are the coefficients, means number of moles of the reactants. Small c and capital small d are the number of moles of products. Here change in enthalpy is calculated in such a way that delta RH means change in enthalpy in chemical reaction is sum of enthalpies of a product to sum of enthalpies of reactants, and we get the change in enthalpy in the chemical reaction. Here delta H C. Here enthalpies of product, enthalpy of reactant. Here C into enthalpy of C plus D into enthalpy of D minus A into enthalpy of A plus B into enthalpy of B. Here HA, HB, HC and HD are the molar enthalpies of the reactant and product. Here respectively, here the enthalpy is calculated in such a way delta RH is equal to summation of enthalpies of a product minus summation of enthalpies of a reactant. Means summation of enthalpy of a product minus summation of enthalpy of a reactant. reactant. And here the difference between these two means enthalpies of product minus enthalpies of reactant, and we get the enthalpy of a chemical reaction in delta H. And definition of this enthalpy of chemical reaction is defined as from this equation. From this equation we calculate the enthalpy of reaction. And here enthalpy of reaction is the difference between sum of enthalpies of product and sum of enthalpies of a reactant, in which in each substance in a definite physical state, in each substance in a definite physical state, and amount represent is this amount. The amount represent by the coefficients in the chemical reaction are called as enthalpy of chemical reaction. Here in this reaction, whose coefficient is A, B, C, D. These are the coefficients, and that coefficients show the number of moles of that particular substance of reactant and product. Here again see the definition of enthalpy is the difference between sum of enthalpy of product and sum of enthalpy of reactant. With each substance a definite physical state, and the amount is represented by coefficient in a balanced chemical equation is called as enthalpy of chemical reaction. Here this is the enthalpy of chemical reaction. Do you understand the enthalpy of reaction? And that is denoted by vector delta RH. Then next we see exothermic and endothermic reactions. These both are related to again heat, endothermic reaction and exothermic reactions. Here endothermic and endothermic and exothermic reaction. Endothermic and exothermic reaction. Here these two reactions are related to heat, endothermic and exothermic. Endo means the amount of heat released in this reaction, that reaction is called as endothermic. The amount of heat absorbed in the reaction is called as endothermic reaction, and the amount of heat released in the reaction is called as exothermic. जे heat काय होते release होते ज्या reaction exothermic reaction, and heat absorbed in the reaction, that reactions are called as endothermic reaction. And the endothermic and exothermic reactions depends upon the values of enthalpies of product and enthalpy summation of enthalpy of reactant, enthalpy of product and enthalpy of reactant. Here summation of enthalpy of product product and summation of enthalpy of a reactant. And here the summation of enthalpy of a product is greater than summation of enthalpy of a reactant. That type delta RH is positive. Delta HR is positive and the reaction is endothermic. Here the value which is positive and reaction has the endothermic reaction. Again, on the other hand, the sign is changed. Here summation of enthalpy of product is less than summation of enthalpy of a reactant. Here the value of delta RH is equal to negative and the reaction is exothermic reaction. Means the enthalpy of reaction is positive, that time the reaction is endothermic reaction, and when enthalpy of reaction is negative, that time the reaction is exothermic. This is the exothermic reaction and endothermic reaction. In case exothermic reaction, amount of heat is released in that reaction and the sign is a negative, and endothermic reaction the amount of heat is absorbed in that reaction, and delta RH means enthalpy of reaction is positive. That is called as exothermic reaction and endothermic reaction. Next we see the standard enthalpy of reaction. Standard enthalpy of a reaction. Next point, standard enthalpy of a reaction. Standard enthalpy of reaction. Standard enthalpy of a reaction. Here standard enthalpy of reaction means the reaction containing the reactant and product, and that reactant are formed by particular element or its constituent elements. Also product. That different reactions carrying a same set of conditions is called as standard enthalpy of reaction, and that is denoted by delta H0. Here zero sign comes on the delta H0, that reaction is the standard enthalpy of a reaction. Means their constituent elements are in the standard state, and the standard state means their temperature, pressure, concentrations are same, and that under same condition reaction is carried out. That is called as the standard enthalpy of a reaction. Here is the thermodynamic standard state. Thermodynamic standard state. Dynamic standard state. in pressure is 1 bar. Temperature is 298 Kelvin and concentration is 1 mole. And these conditions are followed by reactant and product. That is called as a standard thermodynamic standard state or the standard state of a reaction. And here the thermochemical equation. If you write the thermochemical reactions, some guidelines. You write the standard state of thermodynamic reaction, and there are some guidelines are given, and that guidelines are such that is the thermochemical equations. Thermochemical equations. We write the thermochemical equation that has given the some guidelines. Thermochemical equation. Thermochemical. Consider a thermochemical equation, and that example is methane gas, CH4 gas, plus SO2 gas gives out CO2 gas plus twice H2O liquid, and delta RH0. The standard enthalpy of reaction is equal to minus 890 kilojoules. Minus 890 kilojoules moles. Here in this reaction, this is the general equation. Methane is a reactant with oxygen to form carbon dioxide and water. First write the balanced chemical equation. The balanced chemical equation means here the number of atoms in a reactant is equal to the number of atoms in the products, both are equal. That is called as a balanced chemical equation. Here in this reaction, here is one carbon, here is one carbon. Here 4 hydrogen, here also 4 hydrogen. Here 4 oxygen, here 2 plus 2 oxygen. Means all atoms in the reactant and products are same. Hence that reaction is called as balanced chemical equation. Means this is the balanced chemical equation. Here the change in enthalpy in this reaction means delta RH0. The standard enthalpy of in this reaction is right on the right side of the equation. Equation is right side like this. The enthalpy change as and then sign. Here we write the right side. Then third step, this is the second and the third step. In this reaction, physical state means the reactants and products are solid or liquid or in gaseous state or in aqueous form. Here, this is the methane I write here Z. Means this methane is in gaseous state. Here oxygen also in gaseous state. Here CO2 also in gaseous state. And this is water in the liquid state. These are the physical states. जो कोणते इक्वेशन राइट करताना ह्या कॅल्क्युलेट असतात त्याच्या states. Then the reaction is carried out in the direction. In direction, the forward direction and change in enthalpy delta RH is standard enthalpy change is minus 890 kilojoules per mole. We reverse this reaction. That time, this value is completely opposite. Here we write this equation in such a type: CO2 gas plus twice H2O liquid gives out CH4 gas plus twice O2 gas. That time delta RH0 is equal to is plus 890 kilojoules per mole. जर आपण साइन काय केलं, चेंज केलं, रिएक्शन काय केली, रिव्हर्स केली, तर त्याची चेंज इन एन्थाल्पी पण काय होते, कम्प्लीटली अपोजिट. म्हणजे जर ते पॉझिटिव्ह असेल तर काय निगेटिव्ह, व्हॅल्यू सेम असते तर काय ती व्हॅल्यू काय होते, अपोजिट असते. And then last point, the coefficients means here is 1, here is a 2 coefficient, here is also no coefficient, so we consider 1, here is 2. These coefficients shows the number of moles of that particular compound. Here in this reaction, here is a no coefficients, means methane has 1 mole methane. Here in oxygen, 2O2 means 2 half coefficient is 2 moles of oxygen. Then here no coefficients means 1 mole of CO2. Here 2 is a coefficient means 2 moles of water. These are the guidelines to the return of the chemical reaction. And then we see next standard enthalpy of formation. Standard enthalpy of formation. Next point is standard enthalpy of formation. कोणत्या रिएक्शनची आपल्याला काही करायचे असेल, स्टँडर्ड एन्थाल्पी फाइंड आउट करायचे असेल, स्टँडर्ड एन्थाल्पी ऑफ फॉर्मेशन. Standard enthalpy of formation. Of formation is denoted by letter delta F H0. Here F means formation. Standard enthalpy of formation. Here standard enthalpy of formation means the compound is formed. That time their constituent elements are in the standard state. Means the temperature, pressure, concentrations are all the same. Here the definition of standard enthalpy of formation delta FH0. Here standard enthalpy of the formation, standard enthalpy of formation of a compound, standard enthalpy formation of a compound is defined as the standard enthalpy of compound in the reaction, accompanying in which 1 mole of pure compound is formed. from its standard states of element, that is called as standard enthalpy of formation. Again, see the definition of standard enthalpy of formation. Standard enthalpy of formation means the standard enthalpy of formation of compound in a reaction in which 1 mole of pure compound, 1 mole of pure compound in the standard state, formed from its standard constraint elements is called as standard enthalpy of formation. जे कोणताही कंपाऊंड काय होत असतं, फॉर्म होत असतं, जिथे स्टँडर्ड कंपाऊंड फॉर्म होत असतं, कशापासून फॉर्म होते, त्याच्या एलिमेंट पासून. That is called as standard enthalpy of formation. Here standard enthalpy of formation is in this reaction. Here carbon is a solid plus twice H2 gas fuse out. In this reaction, you got CH4 gas, and that time delta EH0 is equal to standard enthalpy in the formation is minus 74.8 kilojoules. Minus 74.8 kilojoules. In this reaction, this methane molecule is formed. 1 mole of compound, 1 mole of pure compound is formed in the standard state from its standard elements. These are the standard elements. या element पासून काय होतं, हा compound काय होतो, form. And then the change in enthalpy, that is called as standard enthalpy of formation, that is 74.8. And here we calculate the standard enthalpy of reaction by using, here this equation is used, delta FH0. The standard enthalpy formation of the reaction is equal to summation of enthalpy, standard enthalpy of a product minus summation of standard enthalpy of a reactant. Means sum of enthalpies of product minus sum of standard enthalpies of reactant. And difference between these enthalpies are the standard enthalpy of formation of a reaction. This is a simple definition. The standard enthalpy of formation of a compound in a reaction when 1 mole of pure compound of a standard state is formed from its standard element is called as standard enthalpy of formation, delta H. This is calculated by using this formula. We will calculate the enthalpy of formation. And then next, standard enthalpy of combustion. Standard enthalpy of combustion. Standard enthalpy of combustion is denoted by letter delta CH0. This is the symbol of standard enthalpy of combustion. Here combustion means 1 mole of substance is completely burned or 1 mole of substance completely reacted with oxygen, or 1 mole of compound is completely oxidized, that is called as combustion. Combustion means to burn or to react with oxygen. And here standard enthalpy of combustion means the standard enthalpy change accompanying in a 1 mole of compound. 1 mole of compound is a completely react with oxygen or completely oxidized is called as standard enthalpy of combustion. Standard enthalpy of combustion. Here, one example: C2H2 is acetylene gas is a react with oxygen. Means 1 mole of compound is a react with oxygen. Here 5.2 O2 gas. 1 mole of compound is completely react with oxygen, or 1 mole of acetylene is completely burned. That time the product is formed, and that is twice CO2 gas plus twice H2O. Twice H2O. Here in this reaction, now here is only 2. Here C2H2 acetylene plus O2, here by CO2 and 1. And here in this reaction, delta CH0 is equal to minus 1300 kilojoules. 1300 kilojoules means 1 mole of compound is completely oxidized. Completely oxidized. That change in enthalpy in that reaction is called as standard enthalpy of combustion. Means the definition of this: standard enthalpy of combustion of a reaction is accompanying a 1 mole of compound is completely burned. That change in enthalpy is called as standard enthalpy of combustion. Here we completed the standard enthalpy of combustion. Then today we see thermochemical equation. In that thermochemical equation we see enthalpy of reaction, then endothermic reaction, exothermic reaction, then standard state, how to write the balanced chemical equation. Then we see standard enthalpy of formation of compound, then standard enthalpy of combustion. These points today we are discussed, and now we have stopped here.